Hello, my name is Tim Althoff. I'm an assistant professor at the University of Washington in computer science, and my specialization is in data science. I think the Neighbor Connect Foundation that I have this opportunity to share a talk on data science with you all in the context of SEF 2020. The University of Washington, I lead the behavioral data science group. In this group, we develop computational methods which leverage large-scale behavioral data to extract actionable insights about our lives, health, and happiness. And we apply these methods to high-impact applications, including informing the COVID-19 response, online misinformation and polarization, mental health, and public health. Why is data science useful? Well, for the first time in history, we have a lot of data. It's not anymore about how we can produce more data, say in the context of perhaps scientific simulation and large-scale physics experiments, but we have abundant data, and the challenge is to analyze this data to extract value and knowledge from this. But how can we extract this value? Data science is a science, and therefore is a systematic enterprise to discover new knowledge by answering questions through data. And typically, this starts in the external world, so external to computers. If you have a question in the real world and you want to operationalize this question to gather new knowledge through data. And what data science can enable is that we can measure new things, new constructs, new questions of the external world and make them amenable to computational and quantitative analysis. Data science also contributes computational methods to then analyze all these data and to extract this value and this knowledge. And then we can interpret the results of these methods to derive actionable insights that we can then use to impact the real world in some positive way. What are the challenges in data science? Well, this is a science, and the challenges are very related to science. In fact, they track the well-known scientific method that we've known for hundreds and hundreds of years very well. At first, we want to start with asking an actual question, not kind of analyzing data without a clear direction, but it has to start with a question. We can then state a hypothesis of what we might think is the answer to this question. And what allows us to do this is understanding of the domain that we're studying and related theory. Third, we can make a testable prediction that would provide evidence in favor of our hypothesis if this prediction was correct. Here we need to think about construct validity. Are we really measuring what we think we're measuring? And does our prediction match our original question and hypothesis? We can then test this prediction. We are an experiment involving data. And this is the only part where this kind of data science method is really going beyond what we have long known as a scientific method, because we will test this prediction. We are an experiment involving data, often lots of data. Here we need to think about internal validity. We need to think about are there other factors that could explain what's going on in this experiment, what we call a confounding factor, and are the findings robust? If we change small amounts about our experiment, do we still see the same results? And finally, we will draw appropriate conclusions through analysis of these experimental results. And here we need to think about our data science models. To what degree can we actually interpret them? What does it mean? And when we make conclusions about something larger than the context that we're studying, we need to think about external validity, because typically our data sets only have an incomplete picture of the external world, of the real world that we actually want to study. So our goal is to make valid inferences from data. What I want to point out is that kind of prediction or correlation is not enough most of the time. There's many funny examples of what is correlated with each other. What I'm showing you all here is how well the number of worldwide non-commercial space launches correlates with sociology doctorates. To the best of my knowledge, these two have nothing to do with each other, but we can see how well these time series track each other over time. So it's very possible to predict one time series from the other, but it doesn't mean that there's any causal relationship between the two, of course. So I think we can think about data science as how we can turn observational flawed and biased and perhaps scientifically weak data into the strongest possible results. This is the goal because it is realistic that all data sets have some kind of limitation. The question is, how can you get the most out of these data sets? And I said, prediction is not enough. Typically, we're interested in causality or causal inference. We're interested in cause and effect. Would taking perhaps a drug actually lead to improvement in the health of our patient or not? And we can quantify causality through this following interventionist definition. We would say that a treatment T causes an outcome Y if changing that treatment T leads to a change in Y, keeping everything else constant. And this is really the important part, that the only thing that would be changing is this treatment. And here we're asking, what if we did X, what if you had taken this drug? Or we're asking about counterfactuals. Was it the drug that helped you to get better? What if you had not taken the drug or taken a different drug? And this is really, really important for decision-making. I'm going to show you real data from a health study in the 1980s that was about kidney stones. And this was the data that they were working with. They had 2 different treatments, and they were wondering which of the 2 treatments does actually work better to treat kidney stones. And what they found was, overall, patients improved more often in the treatment B condition, about 83% of the time, relative to 78% of the time. So that really sounded like treatment B is the better treatment. People seem to be better off. But if you actually looked into the details, you would actually find the exact opposite to be the case. Scientists call this a Simpson's paradox, because it's a paradox that in this case, treatment A is better in both for small kidney stones in the first row of this table, and is better for large kidney stones in the second row of this table. So here the stone size was a confounder that was previously not taken into account, but when you do, the best choice actually reverses. We wouldn't say anymore, yes, treatment B is what you should do. Treatment A is actually better at every single condition that is in this table. And what was going on here is that small stones are easier to treat. It's more likely that patients see good outcomes, but treatment B was applied to these simpler cases of small kidney stones more often, and that way it looked like treatment B was better, even though in fact treatment A was better all along. Now, how researchers in medicine get around this problem is that the gold standard of causal inference are randomized experiments. And this study was not randomized. If it had been randomized, treatment A and treatment B would have seen about the same number of small stones and large stones. So part of this problem came that they used existing data, which is very common in data science, that use existing data to come up with these inferences. However, it's not always possible to do these experiments. If you can, it's often a good choice, but in so many cases, we cannot conduct these randomized experiments or A/B tests. And there's many reasons for that. One reason is practicality. You might exposure to a certain treatment may be hard to manipulate. For instance, if you want to study air pollution or the weather, it's not in our power to change the weather in whichever way you would want to study these environmental effects. You have to study the effects of the weather that is actually happening. There may be ethical concerns. If you're studying things that have negative effects, you can't actively assign this negative treatment to somebody. That is unethical. So for example, as perhaps crazy as this sounds, there's a lot of interest in studying suicide, and there's evidence that suicide is actually contagious. You observe other people taking their lives. People are more likely to do so as well. This is really important to study for the safety of everyone. However, of course, we would not conduct an experiment where you assign suicide at random. Of course, it's unethical. It does not make sense. And I use this extreme example exactly to illustrate that. The last reason is efficiency. Experimental science is expensive and it takes time. So for instance, if you're interested in the impact of a drug on mortality 10 years later, well, it will take you 10 years to collect this data. You're not able to say anything in the meantime. So if you want to make faster progress, perhaps there's existing data that you can use to study these dynamics and make decisions and act changes even faster. What I want to do next is I want to give you an example of a data science project that we conducted recently that is about empathy and that will illustrate many of these challenges as well as the potential impact and opportunities. So we will go through this circle here. We will talk about empathy and mental health support. And then we will talk about how data science methods we developed first allowed us to measure empathy in mental health support from kind of textual transcripts of people talking to each other. We then developed computational methods that we use to interpret how important empathy is in the real world and develop methods to give actionable insights and give feedback to peer supporters in mental health so that they could express empathy more effectively. Empathy is the ability to understand the emotions and experiences of others. Empathy is a key component for providing effective and successful mental health support. And it's been shown over and over again. So it's a really central kind of social skill that is important in many settings, including in mental health support. And we collaborated with a large online platform that is called TalkLife, and they're the largest peer-to-peer support platform. So this is a social media platform similar to those that you might be familiar with, for example, like Twitter. And people communicate on this platform, but the entire platform is created to have peers, kind of everyday people without kind of therapist training, help support each other. So let's say somebody shares on this platform and people share real struggles on this platform. Let's say they say, my whole family hates me. Somebody might reply, try talking to your friends. It's not the worst response, but it doesn't actively communicate empathy. If instead, perhaps this person could respond, I could imagine that this makes you feel really isolated. So they're interpreting what this other person going through, and they're interpreting that the situation might make them feel isolated, and they're labeling what might be going on. So this would be a more empathic response. And in this data science project, we collaborated with clinical psychologists at the University of Washington, as well as Stanford University, to build tools that can measure empathy expressed in text. So they can look at this text message and say how much empathy is expressed in this text. We then were able to apply these computational models to this large online platform and study how often kind of empathy happens and what kind of outcomes empathy is associated with. And what we found was really good news. Whenever empathy was expressed, it was followed by more likes, more replies, and people, it was associated with more relationship forming. So if you look in the graph on the top right, whenever there was more empathy expressed, the likelihood of the person in crisis following the person responding increased significantly when there was more empathy expressed. And this is consistent with theory in empathy, that empathy is related to building relationships. However, there was also unfortunate news. We found that empathy was rarely expressed, even in a situation where we all agreed this is a really good opportunity to express empathy. Empathy was typically very low. Our scale went from 0 to 6, and it was about 1 out of 6 on average. And we also found that supporters would not learn empathy over time. If anything, they might not get better or even unlearn to be empathic in these situations. However, this presented a really important opportunity. We found that peer supporters may express higher empathy if they got feedback. And in this case, we developed artificial intelligence or machine learning tools that can give concrete feedback to help somebody express empathy. So I'm going to show you a little demo of how this tools works. First, I will show you just how the platform works in general. So this would be the control group that doesn't get any feedback. So they would see at the top what we call a seeker post, somebody sharing that they're struggling. And in this case, they're sharing, my job is becoming more and more stressful with each passing day. And now people can write a response. And typically people have no help. There's just an empty chat box and you need to write out this response. So let's say I will do exactly that. And I will write, don't worry, I'm there for you. And this don't worry is not ideal for empathy. Kind of clearly this person is already worrying, and that might kind of feel invalidating if I tell them not to actually worry about this. So the tool that we built was giving feedback, similar how different kind of programs might give you feedback on your spelling or your grammar. This tool was giving feedback on empathy expression. So here I could write out the exact same response, but then I could click on the top, would you like some help with the response? And I'm going to get feedback. So I'll do that right now. Then it takes about a second, and then we get feedback. And here, the algorithm that we trained on lots of data realized, don't worry, was maybe not such a good idea. You can replace that with, it must be a real struggle, for example. And it also suggested to insert a little extra at the end here. Have you tried talking to your boss? This is a question that kind of tries to explore more about what the other person is going through. And therefore, this message would be more empathic. Now, the really exciting part of this work is that this AI feedback resulted in conversations with higher empathy. We evaluated this in a variety of ways, but we also asked other human peer supporters. Here's two messages. I will not tell you which one comes from the kind of human plus AI collaboration condition, where they actually had access to feedback. And you tell me which one of the two do you prefer? Most of the time, 47% of the time, people preferred the human plus AI responses, where people have feedback and they only preferred the human-only responses, kind of the status quo or the control group, 37% of the time. So I just told you about just an example data science project we've been involved recently in that project. I like this example of data science because it started with measuring something that wasn't possible to previously measure in text. We could kind of build computer algorithms that can measure how much empathy there is in a text, and that allows us to study whether people are empathic and what the impact of that is. And I believe that this data science work can have a very significant impact on society. In fact, this and other work of our group has impacted 3 collaborating mental health platforms that collectively have millions of users. These techniques and data science research has improved how they train counselors on these platforms. It has improved how they design these platforms, and it has informed how they moderate conversations on these platforms as well. And I believe that data science tools could help improve access to, as well as quality of, mental health support. Also in academic settings, this work has been recognized by several awards. I want to finally give you some advice on how to think about data science and how to study data science. It's very easy in data science to kind of just analyze something or analyze many things. I want to recommend that you start with a question, with a research question, with a concrete question, and that will help you focus your analysis. And kind of clearly define what the goal of these analyses are. But there are many questions you could be asking, many questions that can be answered with data. And I think you can maximize your impact if you're able to choose, of all the questions that you could answer, choose one that would have a very significant impact if you were able to answer it. As you're going through your analyses, consider robustness. You can always consider multiple ways to do your data analysis. There will be many decisions you can do along the way, how you treat the data, which methods you will use. And it's often a good idea to try multiple of these approaches and to check whether you get similar answers, similar results. And that we would call a kind of robustness in the analysis. And this is really important because often we find that if you change small things about the analysis, you get completely different conclusions. And therefore, we shouldn't kind of rely on these kind of particular answers that may or may not be correct at all. Lastly, pay attention to how you communicate your results. Try to tell a simple story about your findings. It often requires lots of work and doing lots of analyses in this project, but do not try to kind of share every detail about your path to get to your findings. Tell the simplest story for somebody to understand what you did and what the most important findings were of your analysis, rather than telling them everything. With that, I want to summarize. I told you about data science today. Data contains valuable knowledge, and the question is how we can extract that. And data science is a systematic enterprise to do exactly that, to discover new knowledge by answering questions through data. And I told you about an example project of using data science to better understand and support empathy expression. And I'm listing a URL here if you're interested in this project and where you can learn more as well. With that, I want to thank the Neighbor Connect Foundation again for the opportunity to share this work with you. I hope you have a great time at the conference. Thank you.